Hi everybody, I am Pradyut Mukherjee from MMD Exams Guide, your shipmate to success. I shall be presenting various marine engineering and other ship related topics which will help you as a marine professional. So, please like, subscribe, share, and comment on my videos. Keep watching my instructional videos. Thank you. Hi everyone, good day to you. I bring to you today a new chapter regarding a new topic which we shall see is boiler safety valves. No, I shall not be discussing about the constructional features of a boiler safety valve. Rather, I would be discussing about the lift of a safety valve and how that is to be calculated. So as you can see, the safety valve must never be less than 38 in diameter. And the area of the valve can be calculated from this formula. This is the formula C into A into P is equal to 9.81 into H into V. Now let us see what these alphabets stand for. So where H is the total heating surface area, the H is the total heating surface area of the boiler. He is the evaporative rate in kg of steam per meter square of heating surface per hour. P is the working pressure of safety valve in meganewton per meter square. A is the aggregate area through the seating of the valves in millimeter square. So that's said and done. Let us just proceed further. So, and C is a discharge coefficient whose value depends upon the type of valve. We'll just go back to the previous formula. We saw A, P, 9.81, H and C. So this C is a coefficient of discharge and it depends on valve to valve. For example, C would be 4.8 for ordinary spring loaded safety valve. The value of C would increase to 7.2 for high lift spring loaded safety valve. It would increase to 9.6 for improved high lift spring loaded safety valve, and C would be 19.2 for full lift safety valve, and increase to 30 for full bore relay operated safety valve. So these are the different values of C depending on the type of safety valve. So if we consider a boiler operating under fixed conditions of discharge rate, that is the heating rate or the surface area of heating into the evaporative rate into and the pressure, they are all constant, then from this formula which we just saw, we can say that A into C, we keep this on one side, put P onto the other side. So we get A into C is 9.81 into the heating surface area into evaporative rate divided by the pressure of the lifting pressure of the safety valve. That would be constant. So we got this constant, hence we can say that area of the safety valve into the safety valve constant, discharge coefficient is a constant. But A is proportional to the diameter square of the valve. Area of the valve is proportional to diameter square. So D square into C is a constant. Instead of A, we put D square. So we can say that D square into C is a constant. Now we see the fun start. Hence, if C is increased, then D must be reduced because the product of the two is a constant. If this is increased, to keep the product a constant, the D has to be reduced. But if the D is reduced, the area of flow of the steam will get reduced So pressure will accumulate. So the lift has to be increased. So the D is reduced, the lift of the valve has to be increased. As the C is increased, as we saw, the value of C increases depending on the type of safety valve. So typical valve lifts are as follows depending on what type of safety valve we are dealing with. Like C will be 4.8, lift will be D1 by 24 for ordinary spring loaded safety valve. C will be 7.2, then lift will be D2 by 16 for high lift safety valve. If C is 9.6, then lift would be D3 by 12, that is improved high lift safety valve. If you notice, as the C is increasing, obviously the D is decreasing, but by reducing the denominator, we are increasing the lift. The lift is increasing as the D is decreasing. Naturally, D1 is the largest diameter. This is smaller than D1 and D3 is smaller than D2. But the lift is increasing because distinctly we can see that the denominator is reducing, which results in a increased lift. So let us proceed further. We have just seen it for the three types of safety valves: ordinary spring loaded valve, high lift safety valve, and improved high lift safety valve. Still, some more types of safety valves are left. For full lift safety valve, we saw that C is 19.2, lift will be D4 by 5. You see how the denominator is gradually reducing, which results in an increased lift of the safety valve. And lastly, we know C is 30 for a full bore relay operated safety valve, and the lift would be D5 by denominator 4, wherein of course D5 is the least diameter. The diameter gradually increases in this direction, and from D1 to D5 the diameter gradually decreases. And as the diameter decreases, we saw that by reducing the denominator, the lift of the safety valve is increased. So that's all for this chapter. I shall be back again with some new such interesting